Hello, ladies and gentlemen. My name is Decryption, and I hope you are well. Have you ever seen that in games, when you complete a certain quest or you perform an action, something like that, the world changes and it tends to stay there throughout the entire lifespan of the game? So, for example, in Grand Theft Auto San Andreas, on the mission reuniting the families, where you're driving away from the police, you crash through a billboard and it creates a hole in the billboard. That is then there forever throughout the game that you've crashed through the hole. Or games like Dying Light 2, if you give waters to the peacekeepers, then grass grows everywhere because there's more water. Or games like Assassin's Creed, where you pay or you complete a quest to rebuild a monument, the monument is rebuilt and it stays there throughout the entire game. Things like this is what makes the game feel lived in and real. It can really make your game feel from one static basic thing to something where, as you play it, you physically molded this world. So in today's tutorial, we're going to take a look at creating something called the World Controller. A subscription-based system where we can tell any actor in the game, if this change happens, you change with it. So let's get started. So this system's going to be quite hefty, but I've built it in a way where it's so lightweight, it shouldn't cause any frame drops unless you're loading something massive in. So it should be really nice for a lot of scenarios. So the main reason I'm thinking of this system is I always like it when you do a quest and the world changes for it. So say you finish all this guy's quests, and then because you've done him so well, he's got more money, he's got loads more crates around here. Little bits like that we can do. However, in a far upcoming tutorial, because I've got lots of work to do before then, I've actually got a quest all the way over at the castle over here, where you team up with some rogue bandits who are, they're kind of like terrorists, if you wish, in the game. And you've got an option to team up with them, and their goal is to completely wipe out the elven race. They despise them, they don't want them, whatever. And the quest is going to have you somehow, once I've done lots of work, crawl up the back of here and poison the water supply back here, and it's going to completely decimate this entire elven village where the bandits and the rogues, the bad people, are going to move in, and it's going to be their home from now on. So all of the statues, all of the clean look, that's all going to be removed. And that's a huge world change event that I'm going to be doing, which is why this system is going to be perfect. We're going to be building this system in a way where it can handle huge changes like that, so thousands of actors, or just smaller amount of changes, like, a few crates spawn around here. All little stuff like that we're going to look at doing. So this system isn't complex, but it has had to be mapped out on a flowchart because it has got quite a few little points to it. So we are going to be using the game instance to control the world event tags. These are things that I've changed in the world. So for example, world event.elven village destroyed will be one of my examples, or world event.rich port shopkeeper, something like that. All these events that you can change, they'll be set and stored on the game instance. The reason we're doing that is because if you've got one big level, then you can easily have access to it. If you've got multiple levels, then you can always recall the world event tags and you know what's changed. Then we've got the world controller, which is going to be one of the key things we're going to be working on. And this is just going to sit in your world as a global actor. All its job is to handle all the world events it needs to do. So it'll go off and tell each individual actor, you do this, you do this, you do this. And it's just got three simple functions on it: get and set world event tags, and that just goes back to the game instance. But the difference with the set one is that also propagates out to all the children that needs it and tells it to run its change. So for example, if we set the world tag of port shopkeeper becomes rich, then it finds every actor that needs it and then it tells it to run its change. It also has a has tags function just so we can actually check if it's got the right tags to run something. The player controller just has a simple reference to the world controller, just so we don't have to keep searching for it every time. We'll just do get player controller, get world controller. Because it's going to be loaded in memory all of the time anyway, is also loaded in memory. But the key for all of this is going to be the BP world event actor. This is going to be every single static mesh, data layer, big change that you need to run. And these will all sit in the world, fully turned on and off, streamable by world partition. On begin play, or if the world controller tells it to change, it will run the changes, it will check if the tags are active using the has tags function, so such as when it loads in, has the port shopkeeper sold enough stock, and then it will run its specific change. However, a key thing about it is the world event actor alone is not going to do anything. It's actually got a bunch of sub-children that will do the main heavy lifting, and that'll be the swap mesh, which will literally just be changing a static mesh. So from GTA San Andreas' billboard to GTA San Andreas' broken billboard. Toggle layer, this is toggling an entire data layer. So if you imagine the Elven discussion we had, where we were turning all of this Elven one from a clean, nice look to a destructive, bandit-ridden, graffitied one, we don't want to be looping over thousands of actors and making all their changes at once. So we'll just replace it with a data layer, and it'll just flick on and off from a nice one to a gross, disgusted one. So toggle actor is for one, if you destroy something and it needs to be removed from the world, or you gain access to a new cave, maybe you've unblocked it, something like that, you can just toggle the actor on and off, removing it from the world. So that's the plan that we're going to create today. I'm not going to be able to just do all of my destruction of here and all of the mesh swapping over here because I just don't have those assets yet. So let's jump into it then. So the first thing I'm going to do is open up my game instance, and I'm going to create a new variable called world event tags. Now I am going to be using gameplay tags for this, just because for me it's going to be a lot easier to do a lot of this complex Boolean logic, but you absolutely don't have to use it. You can use something else if you want. But I'm going to set it to a gameplay tag container. I'll make it instance editable. Hit compile and save. Whilst I'm here, I'm just going to create a couple of dummy ones just so we can actually set it up. So I'll click add and I'll go world events dot Elven Village destroyed, and I'll set the source. And then I'll just do another one of rich port trader, just so I've got two basic ones. And now I'm going to come to my game instances blueprint interface just so we can add to it so I don't have to cast to it each time. And I'll just create a single function called get world event tags, and I'll make it output the tags, which will be a gameplay tag container. If you don't have a custom game instance, it's super easy. Right click, blueprint class, search for game instance, then go to edit, project settings, maps and modes, and just set your game instance. If you don't have a game instance blueprint interface, just in your content drawer, right click, blueprint interface, and then add the functions. And then we can apply it to the game instance via the class settings. And now that we've got the get world event tags, I'll just add it to a category of world events. And then I'll add one more function called set world event tags, which will simply have an input of new tags, and I'll drag it into the world event category as well. On the set, just make sure you set it to a gameplay tag instead of container. We only need it to run the one tag. And now on the set world event tags, we'll drag in the world event tags. We'll say if it has the tag that we're passing into it. If it's true, then we want to remove it because it already exists. So I'll get it and I'll just do remove gameplay tag. However, if it's false, then it means it hasn't got it. So we'll do add gameplay tag. So it's basically a toggle instead of a set, really. There we go. So that's the game instance part set up. So we can just wrap that in a comment. World event tags. Next, we can jump onto setting up our world controller. So I'm going to come into my blueprints folder. And I will go into my controllers, right click, blueprint class. Now I call it a controller. It's not actually an Unreal controller as such, like an AI controller, a player controller. It's a design pattern called a controller. It's not the same thing as a controller. So it is just going to be a standard actor. So I'll call it BP underscore world controller, and I'll open it up. The first thing I'm going to do, I'm going to search for partition in the details, and I'm going to untick spatially loaded. This basically means that it will ignore world partition. This actor won't be spawned in or out. It will just always exist, which is exactly what we want. Now, you don't want to tick everything in your game as spatially loaded because you want things to show and hide, but certain things like this, or something that needs to exist like the player controllers, will be global. Now inside here, I'll just create a function called getWorldEventTags, and this will simply get the game instance, it will get the world event tags and return it. Now you might be thinking, why aren't we just using the game instance to return it? You probably could, but I want to try and drive all development through the world controller if it needs to be. Because if anybody sets a tag on the game instance directly, then the world controller won't know about it and propagate it out to the world. Now that we've done that, we'll also make a set world event tag function. We'll pass in an import of the gameplay tag of what we're now setting. So we'll search for gameplay tag. And then the first thing we're going to do is the same thing. We're just going to set the world event tags, and we'll pass in the new tag. So now the game instance will update from the world controller, which is perfect. Next, this is where we're going to go off and update all the individual world event actors, but we haven't got that far yet, so we'll just leave that there for now as a comment. The final function we're going to create is hasWorldEventTags. This is just basically going to call getWorldEvents, but it's going to check if the tag exists. It's just a shorthand function, so we don't have to keep replicating it every time. I'm just going to drag off and do getWorldEventTags, which is just going to call our same function here. And then I'm going to add a input to the hasWorldEventTags called tag. And I'm going to drag off the tags and say hasTag, pass in the tag, exact match, and then it will simply just do a return, returning a true or a false if it has it. Super simple function. So now that we've got the world controller set up, let's pass it to the player controller so we've always got access to it. So I'm going to come and open up my player controller. You can of course do your pawn if you need to as well, but this is something that's going to be used across everything, so I think the player controller is a good place for it. I'll create a variable called world controller, and I'll set it to a type of world controller, which it'll find in my BP world controller. And we do want it to be a hard object reference, so it's always in memory. Then I'll come and find my event begin play. After it's done, just in the middle of it, just right near the start where it's done some basic setup logic, I'm going to drag off and do get all actors of class. I'm going to search for the BP world controller. Then I'm going to get the world controller since it's always going to exist. And then I'm going to set the world controller like so. Just so the player controller always has access to it. I'll wrap that in a comment, get world controller. And then I'll just come and update my player's interface so we don't have to cast to the player each time. So again, I've just created a basic interface, BPI player controller. And I'll add one saying get world controller. I'll add an output of our world controller to BP world controller. Then back on our BP player controller, I'll find the interface and just make it return it like so. Just so we've got an easy way to reference it if we need to. So now that we've done that, let's move on to setting up the actual world event actors. So this is all the individual ones that will sit around in the world. So for example, these crates here may be a world actor, it might be a data layer if there's lots of them, something like that. So I'll come back to my blueprints folder, and in my controllers, I'll just create a new folder in here called world events. And then I will right click blueprint actor, and I'll call it BPA for blueprint abstract because we shouldn't be using the base one, called world event actor, and I'll open it up. So I'll come into the class settings and just tick abstract, and all this means is we can't drag this one into the world. Look, it won't let us do it, but that's perfect because we need to create child components of this anyway. So on event graph, I'm going to delete off the tick and the overlap because we don't need those. The begin play, the first thing it's going to do is actually get the world controller. So we'll get the player controller, and then we'll use our interface to get the world controller. And then the first thing this is going to do is just check if a tag is active. So I'll run the hasWorldEvents tag. I'll promote the tag to a variable. I'll call it world event tag. And then if it's true, then we know we need to execute the logic to actually make this actor do its thing. I'll just add a new function down here, run world event change. And I'm using an event instead of a function because you very well may need to stream something asynchronously. such as the data layer, you don't want to freeze the game, so you want to load it in asynchronously. If that's a function, you can't do that. So we'll keep that as an event. Now that up here we've confirmed that the tag exists, I can just simply come off and call world event change like so. So this basic setup is event begin play. As soon as the game starts, it will check if the world controller's got a tag. So this is great if you're loading from a save or something like that. Then it will run the world event change, otherwise it'll do nothing, which is perfect. The other benefit of event begin play is that also works when world partition hides it. So what I did as a test is I've got this BP distance test, and all it does is print actor loaded, that's it. But what I've done is I'm starting from here, and I'm going to put this actor for the distance test all the way over here, like so. So if that actor's in memory, it will show that it's loaded. So if I start from here, you'll see at the top corner it will print out world actor loaded because it's in memory and it's run the event begin play. There you go, actor loaded. Perfect. However, if I go all the way back over to here, that actor is now unloaded because it's far away. So if I start the game here, you will see it won't say actor loaded because it's not in memory. World partition is hidden it. There you go. So no actor loaded. However, if I start running down here, eventually you will actually see it pop up and say actor loaded. And we'll get to the bridge of the point where it loads it and doesn't load it. And we can walk backwards and forwards in order to toggle it on or off. Say actor loaded, whatever it says. There you go, actor loaded, and it is now popped up. If I back away and then walk back into it, you will see actor loaded again. Perfect. That's exactly what we need. And that is just using begin play, which is why on the actor we've built it in that on begin play, whether you've loaded your save, started a new game, or world partition, it will come in and it will run the change if it needs to. So that means if you're far away from the map and you've got a full billboard, as you get closer to it, it will toggle itself and check if it needs to change. So this is all good, but the only other change we have to make now is what if you're stood next to it as you complete it almost. So say you complete a quest and the actor's in memory and you're not starting a new game, we need a way to tell it to change. And that's what we built into the world controller on the set world event tags here. We need to update all the world actors. So as an optimization tweak, what I've tried to do is find the best way for us to tell every actor that's loaded to change themselves, but also allow actors who aren't loaded to also change themselves. So we've done the actors that aren't loaded or when you start the game, that's perfect. Now we need to implement the world controller to tell all the current actors, but I've currently got 24,000 actors here. Now I don't think all of them are going to be loaded in memory all at the same time, but a good 12,000 actors, I don't want it looping over every single one and trying to see if it's a world event actor. I don't think that's going to be great, especially the heavy casting, because we don't need to cast to something on the world controller all the time. So this is exactly why interfaces are brilliant. So I'm going to come into my Blueprints Interfaces folder. I'll right click Blueprint Interface and I'll call it BPI_world event and I'll open it up. I'll just add one function called onWorldEventChange, and I'll pass in an input of the tag that's now changed. So I'll set the data type to a gameplay tag, and I'll hit compile and save. I'll now add this interface to the world event actor, world event, and I can now implement the world event changed function. And this function is basically going to do the same thing as this one up here. However, it's going to check if the tag is the same as our stored tag instead. So instead of us getting the world controller and seeing if the tag exists, the world controller is telling us this tag's been added. So we're going to say if it equals our current tag that we've stored on the object, then we can do something. However, this world event changed is only telling us the tag. It doesn't tell us whether it's been added or not. So back on the world event, I am just going to come and add a boolean to this saying added. And now that lets us see, should we be affected by this? Yes, we should. And then we can add one more branch after it. Do we need to add or remove anything? Which is perfect. So on the true, because we've added it, we can now call run world event change. On the false, we actually need to tell it to run the world event change, but for the false state if you wish. So I'll just come and add a Boolean input to this one called active tag. And I'll delete the branch and just call it straight away. So should we be affected by this? Yes. Then call it and say whether or not we've added the tag. Then on the begin play, we don't actually need to worry about undoing it if we've removed the tag, because when you load in the game, the tag is either going to be there or not. If it's not there, then we don't need to change it. And then I'll do the same thing on the world event change here, where I just call active tag. So what we've basically got is 2 entry points into this now. The event begin play runs when you first start the game, or you load your save, or you load the object in via a data layer because you get close to it. Interface function runs whenever we tell the world controller to change something, and then they both call this run world event change that we can now set on the child actors. So just before we set the child actors up, let's go back to the world controller. We'll drag off this and we'll do get all actors with interface, and we'll do BPI world event. We'll loop over all of these and we'll just call the world event changed interface like so. So the tag we can just drag back off and do get tag, and that'll do that one there. However, we do need to know whether this was added or not. So we'll jump back over to our BPI game instance, and on our set world event tags, we'll just add an output of, and it'll be a Boolean, compile and save. Back on our GI main, you'll see now it's complaining that the set is an event. So we'll just actually delete that, cut all of the code so we can reuse it, and back on the set world event tags, we'll just paste it here. Connect it up, and then right at the end, we'll add the return for the remove and the return for the add, but the add will be ticked like so. We also do need to pass in the tags here. It seems to have removed them, but that's okay. And we'll just pass it down to here as well. And now back on our world controller, we can now just simply pass in this added to the added there like so. However, due to the way Blueprints works, I don't actually want this rerunning this code to try and get the return value. So I am actually just going to return this to a local variable because it's slightly more performant to do that. And I'll call it added world tags. And what I mean by that is it was a tutorial I saw a while ago on Unreal's own channel where they said Blueprints doesn't cache variables like C++ does. When you do a return value, you can keep using that return value because you'll probably cache it as a variable. Whereas Blueprints, it will recall this event over and over and over again, trying to re-get the return value for what you need, which we don't want. So just for ease sake, we're going to cast it to a variable and just use it that way. And now our world controller is set up, so if we change any world event tags, it will tell each child that needs it, which will come over to the child. It'll say, hey, does this affect you, yes or no? If it does affect you, then change what you need to change, which is perfect. So now let's crack on with the child world actors, which is going to be amazing to do. So I'm actually going to right click this BPA, create child class. I'll call it WEA for world event actor. And we'll do the swap mesh one first because that sounds easy enough. So for the swap mesh, I'll just come and add a static mesh inside this blueprint. So for the swap mesh, you've actually got 2 ways you can do it. You could just add this swap mesh in, say we'll drag it here. We can create a variable on it which references, say, that box, and then we'll point it to an added mesh and a removed mesh, and it can swap between it. Or you can add the static mesh directly into it. It's entirely up to you how you want to do it. I'm simply going to come and add the variables to it so it links out to it. So it essentially just sits there basically doing nothing. So I'll add a variable to it, actor static mesh to change. And I'll set this to a type of static mesh. And I'm going to set this to a type of static mesh. And this one needs to be an object reference because it's referencing an object in the actual world. However, the next variable we create is going to be our static mesh added. So this is when the tag's active. This will be a soft object reference, which will let us select the content drawer assets. And then we'll duplicate this and do tag remove. And we'll hit compile and save. Now on the event graph, I'll delete all this code here because we don't need it. And the only function we need to overwrite is our run world change event, like so. And you'll see we've got two options, the call and the add. We want the add one. I am going to right click and choose add call to parent function. All this allows us to do is override the function on the BPA world event actor. But if we ever add anything in here that we want all actors to do, say some dialogue plays, hey, I've unlocked something, you know, something like that, we can have it run it. But then we can continue on our normal route. So I'm going to get the static mesh to change here. And I'll drag off and do get static mesh component. And one slight mistake I've made, the static mesh to change needs to be a static mesh actor. Otherwise you can't actually change it. So we'll just change that over. And now we can drag off and do get static mesh. And you see we've got the static mesh component. And then from this we can drag off and do get static mesh, like so. So the reason we want to get it, and we also want to set the static mesh as well, is so then we don't have to set it if it's already set. So for example, it could be that this actor isn't loaded in the world yet because you've not reached it, but when you reach it, you haven't got the tag, so it doesn't need to reset itself because that's going to be more performance for it to set it, re-render the new mesh. So we may as well just check if it's the same one and then not do anything. What I mean by that is if we grab these three lines here, drag off the static mesh and say equals equals, then we can check the static mesh it currently has. So I'm going to drag back off of this and do select. So I'm going to drag in a branch over here and connect it up like so, and to the condition to the active tag. If it's added true, then we need the added mesh here. So I'll drag off and do async load asset. And then just under it, do resolve as well. Connect it to the true. I'll do the same thing down here, but instead of the added, we'll do the removed and connect it up to the false. So now we've got them two loaded, we can actually check it against this mesh to see if we need to change it or not. So I'll just come down here and add a custom event, static mesh loaded, and we will pass in the static mesh that we've just loaded in memory up here, and that'll be a type of object. And now we can call this static mesh loaded on the completed, static mesh loaded, passing in the loaded mesh, and we'll do the same thing for the removed one, like so. Now that we've done that, we can drag all this code here to check the current static mesh, connect this one over to there like so, add a branch, and we can now say, does that static mesh that we've just loaded equal the one that's currently active? If it's true, nothing to do, we're all good. However, if it's false, then we now need to call set static mesh, and we need to pass in the new mesh like so. And that's it, ladies and gentlemen. That is the super basic swap mesh function. So just to jump over this again, as soon as we call run world change event, it checks which static mesh we need. Is it the added or the removed one, depending on the tag? It loads that specific asset in memory and then calls our static mesh loaded function. Inside here, it checks if the current mesh is the same as that one. So if it's a broken box, does it equal a broken box? If it's anything different, it sets the static mesh. And this is as simple as dragging it into the world. And you see, we can point it to what we need. So the static mesh to change will be that one right there, the prop crate. We haven't actually made the two variables instance editable. So let's just tick both of those. And now you can see, we can say for the good crate, we'll use this one. So I'll come in and tick static mesh to be added. For the bad crate, do we have a broken one? Yeah, that looks broken. We'll add the broken mesh like so. The world event tag will be if the port trader has now become rich, like that. So let's give it a try. So I'll just right click and play from here, and you should see the box should remain the same. Nothing should change because that gameplay tag doesn't exist. And just before we try it, I'll press Ctrl P and search for our world controller and just drag it into the world. You can really place this anywhere as long as it exists once. There we go. So you'll now see if we start the game, we don't have the gameplay tag active. It should actually change that crate to the removed broken crate because he's not rich. And there you go, you can see it's now exchanged it to the broken one because he is not a rich port keeper, and that's what we've told it to do. If I come back into the game instance and add the world tag of rich port keeper, and if we run it this time, it should basically remain the same because there's nothing to change. It's already at the rich state. And there you go, it's not changed. Now, just to test if our optimization has worked, I'm actually going to come back to the swap mesh actor, and I'll just add a print statement out at the end. And we'll call it changing static mesh. Now, if that prints out, it means our optimization has failed, and it is still changing it, even though it's the same static mesh. And we don't want that. So we're hoping that we're now going to run it, and it's not going to say anything. There you go. It's not said anything, which is perfect. Just to double test it, if I come back and remove the rich port trader, it should now show that print statement because it is indeed changing the static mesh because he's not rich. Thus, the world event has run successfully. There we go. Changing static mesh. So let's delete that print statement. So we know the swap mesh is all good now. Let's move on to the next one of toggle actor. So this one is kind of the same thing, except it's going to make the actor invisible, and we'll give it an option to destroy the actor. So say you get one chance to save a bridge, you don't do it, it toggles the actor, and then it's gone forever. And with that one, it's a special one, because we actually can make it destroy the world actor itself too. So I'm going to come back to my content drawer. I'll right click on the world event actor. I'll do create child blueprint class. WEA for world event actor, toggle actor. And I'll open it up. I'll delete all the functions in here and just come and override the run world event change. But make sure you do the add event. I'll do a call to the parent and plug it in like so. And now we can do what we need to do. So if the tag has been added, then we need to get the actor that we want to hide. So I'll just create a variable called actor. And I'll set it to our world object of our actor so we can make it instance editable. And now this is where we need to think a bit differently about this one. On the swap mesh, we've got an added mesh and a hidden mesh. However, sometimes you might want to show a mesh when a tag's added, but you also may want to hide a mesh when a tag is added, which is why it's going to be so powerful. So what I'm actually going to do is add a boolean down here, show mesh on added, and I'll set it to a type of boolean. And what this is going to do is say if it's active and that's active, then we need to show the mesh. If that's inactive and that's active, then we hide the mesh. And if active tag is true, but this is false, then we reverse it and we set it to false. So what I mean by that is if active's true or false, then we can add another branch here for the show mesh on added to the true. So if the tag's been added and the show mesh has been added, then we want to get the actor and we want to set actor hidden in game to false. So the actor's visible. However, if it's false, because we shouldn't be showing the actor in game, we can tick it. But then we'll duplicate all of this below itself here and connect it to the false. So if the tag has been removed, should we show it added? So we'll hide it there and we'll unhide it there. And we can hit compile and save. And now that lets us change it in a way where we can make this toggle or untoggle depending on the tag. It gives us loads of flexibility. I'll add another boolean below of destroy on hidden. And I'll make sure these are both ticked as instance editable. And all this is going to do is outright remove it, the actor and the mesh. So it's completely gone. So because we're hiding it in two places, I think it's only going to be nice if we add a custom event. So I'll come down here, add custom event for destruction, add a branch where we add in our destroy on hidden. If it's true, then we get the actor and we call destroy. Equally, if this is something you're pooling, add it back to the pool, but I'm not doing it with this one. And then we can also call destroy on the self, because if the actor that it's tracking is gone, we don't need to track it anymore. And then we can just come up here on hidden, check destruction, and we can do the same for this one here, like so. And there we go. We now have a toggle actor world event. So let's come and add this in. So we'll get our world event toggle actor, and let's say if he's rich, this top box exists, I think. So should we show the mesh on added? Yes. Should we destroy it on hidden? No, we'll leave that one for now. And the world event tag is going to be our rich port trader. So if we try it straight away, it should hide that top box because we don't have the tag. There we go. The box has been hidden. Now you will notice the lid is still floating there. you do have two ways you can solve that. We can either add another world mesh actor and hide the lid. We can make the lid built into the actor of there. We can also loop through all the children, or we can turn this into an array. There's a few different ways you can do it. So what I'm going to do is come back to here, and then when it's actually setting something to hidden or not hidden, I want it to loop over all the children and also make them hidden or not hidden. So I'll add a custom event down here called toggle visibility, and then I will get the actor, and I will drag up and set actor hidden in game, and I'll promote that to a variable just right there. So now we could call this function to show or hide it, but then from the actor, I'm actually going to drag off and do get all child actors, and we want descendants. I'll for each loop over all of these and do set actor hidden in game, bring this back to the variable over here. And now we've got a way to show all the children as well. So I'll bring this function back up here, and we can basically wipe all of this out, really. So I'll add toggle visibility here. We want it false. Get rid of those. This one needs to be true. So we'll tick it, connect it to the destruction, and put it over to there. And then the same ones down here, connect it up, and then the same one here, but will be unticked. And now that should take care of the children part. And one slight mistake I've just made, don't use get child actors, use get attached actors. Child actors are inside a blueprint, so it's anything that you put inside here. Attached actors are ones in the outliner that are directly attached to one another. So you'll now see, since the lid is attached, when we run it, the lid and the box will hide away because he's not a rich portkeeper. There you go, they've disappeared because he's not rich. If we come back to the GI main, make sure he is a rich portkeeper, you will now see that the box remains full, it's not broken, and the box will be visible because he is a rich portkeeper. Which works really nicely, because if he ever becomes unrich because you steal from him, the boxes will slowly disappear around the game, showing life and repercussions in your game, which is really cool. So one more optimization I'm actually going to come and create in here is before we actually call toggle visibility on anything like so, I'm actually going to check if it's already visible before we do anything. So I'll just tidy this up a little bit like so. And then I'll get the actor, and I will get actor hidden in game, like so. And I'll add a branch. So if the actor is hidden in game, and it should be hidden, then we don't need to do anything. Otherwise false, we need to toggle something. Now I'm going to assume on my game that if the parent is hidden, then all the children are going to be hidden. So if I by default make a box hidden, I'm going to assume that I've also done it to the children to save us having to check this each time, because it's a small tweak. And that's a nice optimization boost. But something I will mention about this, I would build your game in a way where for the most players, that's how the game will act. So for example, when I start my game, this guy's not going to be rich. For the majority of the game, he might not be rich until you do his quest. So I'm actually going to come and set this crate to the broken variety. So when the game loads for the most time, it's already set. It doesn't need resetting. And the same with these here. I'm going to come and set them hidden in game. Because for most of the game, they aren't going to be visible. And then that means when I start the game, that's how it's going to look, meaning the world events don't need to run when you first start the game or for the majority of the game. If it's 50-50, it doesn't matter, just do whatever you need to do. Now you might be wondering why we're using single actors to drive all the world events rather than a data table or something like that. So if you're using Unreal Engine 5 and you're using World Partition, you very well may have seen this folder called External Actors in your... And inside here, you've got a bunch of different folders like maps. We'll go into our landscape one, which is the one we're on. Then you've got a bunch of folders. Then you've got a bunch more folders. Then you've got a bunch of weirdly named assets. And this is exactly why we're using single actors instead of data layers. Unreal's World Partition, to make it better and more streamable and make it a better multi-user interface, treats every single one of these actors almost as a completely separate file in your system. So all those files I showed a moment ago will be a segment within this world partition. So we'll zoom into a segment, say this gap here. It will be a square inside here, and then it'll be an actor inside here. So in all of those folders, in those weird names, this cube, the crate, will be a single file. So with that as Unreal's design theory of how it wants to do things, it means adding everything to one huge data table where we show and hide, show and hide, show and hide will work, but it's kind of doing the opposite of what Unreal's building and trying to push. So with the multi-actor system, if you've got version control set up with 3 artists all working on your map, they can independently work on the exact same map and come up with very minimal conflict issues. If they are also trying to build in the world events to say, this guy should have poor things, these stocks should have more things, and they've got to edit the same data table, you're going to get loads of conflicts and it'll mess up. So that's why for this idea, I have gone down the single actor route more. It doubles the amount of blueprints you'll have in your map, but it does mean that it works better with how Unreal's versioning and system is seeming to go. Now for the last world event, let's do our toggling data layers actor. So I will come back to my data layers folder, right click. I'm actually just going to duplicate this one because it saves us setting up the functions. So I'll call it WEA toggle data layer. And I'll open this up. We don't need any of this stuff down here, so that's all good. And we don't need any of that. So we don't need the actor variable, so I'll call it data layer. And we'll set it to our data layer asset. And then instead of show mesh on added, we'll do show layer on added. Because just like the actor, you may or may not want to show the layer when it's loaded or unloaded. And because it's majority of the same, I am actually going to come back and revert putting all this back in with the toggle visibility. Because I think it's a good idea. And it saves us a bit of work here. So we'll add this back in. And we'll line it all up. If it's true, connect to true. False, connect to false. And we'll replace our booleans like so. And it will error about this. Just refresh each node and it'll stop moaning. Like so. Hit compile. And now we've got an error down here, which is all good. So how do we actually toggle the layer on or off? That's the key thing. So the first thing we need to do is actually check if the data layer is visible. So I'll get the data layer. I'll right click and do get data layer manager. Don't use the subsystem, that is now deprecated. I'll drag off of this and do get state, get data layer instance runtime state. We need to get the instance for this, so I'll drag back off of this return value and do get data layer instance from asset, and we'll plug the asset in like so. So we'll get the running instance of it, plug it in, and now we've got the visibility. So we'll say equals equals on the enum, because it's easier to use. Then we can do the same thing down here, and it's hidden. So if we're hiding it, and we'll change this to unloaded, and it's invisible, then we don't need to do anything. It's all good. Let's make some space. However, if it's false, then it means we need to toggle it to a new state. So I'm going to copy these bits of code down here, paste it over to here. In the false, connect it up. And instead of get data layer, when we've got the instance, we will do set data layer instance runtime, connect it to the data layer manager. We'll make it recursive, so if any data layers are within data layers, it also makes them visible. The in state, I'll drag backwards and do select, and then I can drag this one here from the hidden over to the index. If it's hidden, true, then it should be unloaded. If it's loaded, then it should be activated like so. And now we can hit compile and save, and that's it, ladies and gentlemen. So I don't actually have a data layer we can test this on. I think we've got one here. Yeah, we'll use that one. So I'll drag the data layer manager in. The data layer we want to manage is the inside of this house. And it should show when the tag of rich portkeeper is added. Yeah, because this can be his house and he'll have flowers and stuff. So if we try it now, I believe we've still got the gameplay tag on. So he should now have crates on his port. He should have a non-broken box, and he should have a fancy flower house. There we go, ladies and gentlemen. He now has a very fancy house. Boxes like so. However, if we come and remove the tag, compile and save, jump back in, he should be a very poor trader with not a very fancy house, a broken box, and no additional stock. There we go, ladies and gentlemen. Everything is looking good. So there is our world controller system. A super optimized way we can change the entire world really easily. However, there is still one more part that we've not actually tested, and that's on the world controller when we actively make a world change. We're testing it on begin play at the moment, which works, but we need a way to actually make it change the world in real time. So there are loads and loads of ways you can trigger this. All you need to do is get the world controller and call set world event. That's it. But there's so many different ways of doing it. You can do it from dialogue, from a quest, from traveling to a new location, any way you can think. So for me, for quick dialogue demo purposes, I'm just going to add it onto his dialogue. So I'll open his dialogue up. So I'm using the narrative quests and dialogue, otherwise renamed to narrative tales plugin to do this. And you can see when I come and talk to him, he says, do you need any help? I've cleared the bandit camp out and goodbye. So we'll just say if we offer him help and he says sure, we can say after this, where we begin the quest, if you imagine we complete the quest, we can create a custom event in order to toggle that key on the world controller, the tag. I'll just double click into this and say, get the player controller. So this is for everybody who doesn't own narrative. This is how you'd roughly code it in. So I'll get the player controller, get the world controller, and then we can simply drag off and do set world event tag, and we'll do the call function there. The tag we want to add will be our rich port trader, and we can connect it to there. That's how you basically code it in, those 3 lines. For us narrative people, what I'm actually going to do is come and create a custom narrative event, which is super easy to do. So I'll come to my narrative folder and go into my events, right click, narrative event, call it NE, toggle world event tag, and I'll open it up. In the class settings, I'll just give it a name of toggle world event tag. I'll override the function execute event and paste in our code that we've just copied because it's the exact same. The only difference is I'm going to promote this tag to a variable so we can reuse it later. And then I'll also override get graph display text, which I will just make it append this string where I'll say toggle tag, toggle world event, and I'll pass in the tag. I'm going to do get tag name, and I'll pass it in like so. Which now means back on our dialogue, we don't have to code it in, we can just reuse our toggle world event tag. The tag we want to toggle at the end of it is our rich port trader. So it's added it by default. I'm going to actually remove the devalue of it because I don't want that. And there we go. So if we try it now, ladies and gentlemen, if I talk to him, we have coded it in to activate that he now becomes rich because we've just accepted, or in this case, we're imagining we've completed his quest. You will see if we try it now, he should remain a very poor trader at the moment because bandits have kept stolen all his goods. He's not sold anything proper in weeks now. So his house should be lower down because he's had to sell the goods to remain happy. He's got a broken box and not much stock. If we wait for the patrolling guards to go away, we'll talk to him.
Welcome to my shop.
He says hello, and we say, do you need any help with anything?
Yes,
he says,
actually I do.
Bandits have stolen from us. And you say, yes, we will help.
Like perfect.
And you'll see, when we accept the quest,
bandits go to the edge of town.
Everything has now changed. He's now got a fully healed box, he's got more stock, and a very nice house. There we go, ladies and gentlemen. There is the benefit of the world controller system. Now, I did just add it to dialogue to be very, very basic, but going back to the analogy that we had at the beginning with the Elven one over here, what I would do is set up this Elven data layer here. I would then drag in our toggle data layer one over here, set it to the broken Elven data layer, and then we can untick it to show unheaded and do all the other bits we need to do with it. Super easy. And we've got 3 different ways of doing it for small actors, big, huge data layer actors, and setting meshes to be different things. Super nice and reusable. You could even take it one step further on the toggle data layer and add a data layer on added, data layer on hidden. if you really wanted to. So instead of a toggle data layer, a swap data layer, which very well might work better for my Elven one. Super easy. I'll leave that to you to figure out because we've already done that on the swap mesh one. So there we go. World controllers. The games that you can create using this is going to be vastly different. I've tested it against all sorts of things from different AAA games like GTA, Assassin's Creed, Dying Light. It can work with all of them and it should be super optimized. Thank you for watching, ladies and gentlemen. If you've got any suggestions to make this even more optimized, let me know below. My name is Decryption and I will see you next time.